The astronauts read out
the gravitational effect of those planets.
Hi, I'm Matt, and this is NASA Now. Inside the International Space Station, the crew is conducting experiments all the time. Did you know there's a lot of testing happening on the outside of the station as well? Today, our special guest will tell us about MISSE and how the results from this project affect the future of space travel. That's ahead. First, here's what's happening at NASA Now. In February, NASA announced the publication of the 2011 edition of NASA Spinoffs. A spinoff is a technology, product, or process that was originally designed for use in space that also has applications for all of us here on Earth. Some examples include hybrid fuel vehicles, unsinkable life rafts, air traffic control advancements, and even cleaner burning engines to help the environment. You can find thousands of spinoffs developed by NASA by going to spinoff.nasa.gov. When a material is used for a spacecraft, it has to go through a lot of rigorous testing and analysis. Sometimes the testing is conducted here on Earth in special facilities. Other times, when we can't effectively simulate the harsh environment of space, the materials are flown 220 miles up to the International Space Station to MISSE. To tell us more about MISSE and how the materials are tested in space is Senior Materials Research Engineer Kim DeGrow at the NASA Glenn Research Center in Cleveland, Ohio.
Why materials need to be durable in the space environment is very important. There are many harmful environmental threats that can degrade spacecraft materials. For example, in space there is radiation from the sun, there is thermal extremes, there are micrometeorite and debris impacts, and there's something called atomic oxygen, and that can be very degrading to certain spacecraft materials. And so engineers like myself study how materials survive in the space environment when they're being affected by all these environmental factors. The MISSE project is the longest running materials technology development project on the International Space Station. And MISSE stands for the Materials International Space Station Experiment. It's actually a series of materials flight experiments that are placed into trays that we call passive experiment containers, or PECs. And these PECs are placed outside a space station, and materials or experiments that are in these trays get exposed to the space environment for a long duration. There are polymers, also known as plastics. There are ceramics, which are like glass materials. There are composites, and those are mixed materials, so you have polymer and a ceramic together. This is a tray of actual flight samples that we just recently retrieved back from space after being up there for about a year and a half. And we are now in the process of analyzing the samples. This particular sample over here is very degraded. It's actually curled up, and it has an impact site in it. We were able to quantify the difference in the erosion of these different polymers, which is a value that we call the erosion yield. It's a very important value that spacecraft designers need to know to build durable spacecraft. Sometimes we will fly a very thin film polymer like this, and sometimes we fly a very thick material. Sometimes we stack many layers together, and we see how it may degrade or erode away in space through these various layers. The MISSE project is a new project that has very similar goals to our original MISSE project. We want to have a permanent platform on the International Space Station. In the current MISSE program, we had taken up these trays of samples and brought them back down in the shuttle bay. Now what we're going to do is design the new MISSE so that we can take it up on a vehicle such as one of the SpaceX vehicles. And then we need to be able to place this experiment outside space station using the robotic arms, such as Dexter.
For a chance to develop your own version of materials testing, we've got a very cool project for you. Check it out.
Teachers, you and your students can put your engineering skills to the test by creating a thermal protection system using the heat, temperature, and energy lesson found right here on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to visit our Facebook page and leave a comment. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.